to show you how to do a one variable optimization example where y is minus 2x cubed plus 6x squared plus 18x plus 50. And we're going to first find y and y prime, then determine the intervals on which y is increasing and decreasing, and then where the max min are, and then where it's concave up, concave down, and the inflection points, and then we're going to use all of that to sketch the function. So let's start with y and y prime. Okay, sorry, y prime and y double prime. So y prime is just going to be minus 2 times 3x squared plus 6 times 2x plus 18, which gives us minus 6x squared plus 12x plus 18. Y double prime, you just take a derivative of that derivative. So you just take d dx of this whole piece here. Gives us minus 6 times 2x plus 12, which gives us minus 12x plus 12. Gorgeous. That's y prime and y double prime. And now to determine where y is increasing and decreasing, we need to figure out first where y prime equals to 0. So a little note here, y is increasing. Y prime is greater than 0, and y is decreasing when y prime is less than 0. Okay, so let's go figure out first where y prime is equal to 0, and then that's where it's going to change from increasing to decreasing, and that will help us to determine when it's increasing and when it's decreasing. Okay, so to solve for where y prime equals to 0, so we're at negative 6x squared plus 12x plus 18 equals to 0. Okay, oh, sorry. And what we can do is first bring out a minus 6. We're left with x squared minus 2x minus 3 equals 0. And there we go. Let's see if we can make that go away. Sorry about that. Oh, no, maybe not. Okay. And now that leaves us with having to factor this guy. So we're going to look at the last number in here and see which numbers multiply to give us that last number. So minus 3. What two numbers multiply together to give us minus 3? So either minus 3 and 1 or 3 and minus 1. And then we're going to check and see with both of those if they then add to give us minus 2. So the second one here adds together to give us positive 2, so that's not correct. This first one is correct. So our two numbers are minus 3 and 1. Okay, and so y prime is going to factor into x minus 3 and x plus 1. Gorgeous. And now the next question is, when does it equal to 0? That's what we really want to solve for. Well, then we change the signs here. So this first expression, x minus 3, is equal to 0 if x equals to positive 3. So that 3 minus 3 gives us 0. Next one, x plus 1 is equal to 0 when x equals to negative 1. Because again, plus 1, that's right, yeah, minus 1 plus 1 will give us 0. We don't worry about the minus 6, it will never equal to 0. So our two solutions are 3 and minus 1. So y prime equals to 0 when x equals to 3 or x equals to minus 1. Now, to figure out where y is increasing or decreasing, we need to test on either side of these points. We have -1, we have +3, and we need to figure out what y prime is doing on either side of those. So let's test, let's say -2. And let's test 0. It's another nice one to plug in, and +4. You can pick any numbers as long as they're to the left and right of your critical points here. Okay. So we're going to get y prime at -2, y prime at 0, and y prime at 4. Okay. Easy thing to do is to plug everything into the factored version of y prime. So I plug the -2 in, and I get -6, -5, and -1. All I actually care about is the sign. So minus, minus, and minus gives me a minus. Turns out it gives me -30. All I care about, again, is actually the sign. That's all I care about. So what I care about on the graph here is that y prime is 0, or if you will, y is decreasing to the left of -1. Because where we tested at -2, it was negative. Gorgeous. Y prime at 0 is going to give us -6 times 0 minus 3 times 0 plus 1, which gives us positive 18. And again, all we really care about is that it's greater than 0. Sorry, we can make that a bit prettier here. So y is increasing between -1 and +3. So in this whole area here, it's increasing. Good. And finally, y prime at 4. Let's just plug it in up here. It's going to be -6 times 4 minus 3 times 4 plus 1, which gives -6 times 1 times 5, which gives -30. So it's less than 0 to the right of 3. So the next step after this, now that we know where y is increasing and decreasing, is to determine the maxima and minima. So let's do that next. Let's just write this down a little bit prettier. So y is decreasing when x is less than -1 and x is greater than 3. And y is increasing x is between -1 and +3. Now, next part C. here. Looking at the drawing at 3, we have this. We go from increasing to decreasing. So we have a maximum right there. Y at positive 3 is going to give us negative 2 times 3 cubed, 6 times 3 squared, plus 18 times 3 plus 50 is going to give us quite a large number. Let's see what that gives us. Gives us minus 54. Plus 54, plus another 54 plus 50. Those two cancel. We're left with 104. So we have a max at 3,104. Notice, you'll know if you've done something right if your maximum coordinate is higher than your minimum. It should be. Next is to determine where y is concave up and concave down. To do this, we need to look at y double prime, which is minus 12x plus 12. And we're going to solve for where that's equal to 0. That's nice and easy, actually. X just equals to positive 1. And now we just need to test on either side of that and test y double prime. So to the left of 1 we'll just test 0, to the right of 1 we'll just test 2. You could test any values to the left and right and go and plug the 0 and the positive 2 into y double prime. All we care about again is the sign. So y double prime is positive to the left of 1 and negative to the right of 1. What that means is that y double prime is concave up when x is less than 1, and y double prime is concave down when x is greater than 1. Again, concave up means it's opening upwards, and that means that y double prime is positive. Concave down is when y double prime is negative and it's opening downwards. Next here is what are called inflection points. To have an inflection point, y must change from concave down to up or up to down at that point. So in our case, y switches concavity, we say, when or at x equals to 1. Now if they ask for the coordinates or the point, then we need to go plug 1 into the original expression for y. So again, it's that, going back here, minus this guy here. Let's go copy that again. first at -1. Put an inflection point at +1 and a maximum at +3. Just like that. You'll notice that the graph is concave up until that inflection point and then concave down or opens down after.